All right, welcome. You are going to need to write this down. Nice color code. I'm just leaving it here for a while. Not going to pause the video. I'm going to talk my way through it. But while I'm talking, this is the foundational piece for this lesson. Okay, we're not talking about like when the flowers start to leak all over the counter with the water. That would be change of vase. We would need to change a vase there. But this is change of base formula. Okay, we need to change the base of the logarithm. So reading that through as you're writing, please write it, because as you write it, instead of just like printing it out, you will memorize it a little bit better, or you'll understand it. So I'm going to read it through. Any logarithmic expression with a given base, a greater than 0, and a cannot be 1, we've talked about that, can be converted into an equivalent logarithmic expression of any other base, b greater than 0, and b not equal to 1. All right. So we can most definitely change the base and make it look different, but it's equivalent. Don't forget what equal signs mean in math. So follow the colors there. Log is just the word log written in orange, okay? But if you start with something that is base A and the argument is M, okay, you can rewrite that into log new base, whatever you want, okay, as long as it fits these two right here, okay? And you put the argument on top and you put the old base on the bottom, all right? So what does that mean? Well, here's the deal, and we got to take you back to Mr. Smith and I when we were, we're dinosaurs, right? We're old, but our calculators that we had, you could actually not put this in them right here. You guys would hit, when you hit log on your calculator on the Inspire, it immediately does this. It says, what base do you want and what do you want to raise that to? That's what it says. All right. Well, guess what? Our calculators didn't do this. You could only put in base 10 and base E, right? Common logs or natural logs, right? So common log is base 10. So if we wanted to rewrite this right now as a common log, we could. We would write it as log base 10, don't need to write it, of 17 divided by log of 4. So if you don't believe me, I'm not going to go to another screen right now through this video, but I would in class, I would tell you, get out your calculators, type this in, you'll get a decimal. Type this in, you'll get the exact same decimal, okay? So this is equivalent to that. Maybe I should have put equal signs there, which is equivalent to, if we wanted to, we could write it as the natural log of 17 over the natural log of 4. Now, when you hit Control E on your calculator, it automatically pops up natural log. So that's why I personally use the natural log a lot. It's easier to type it into the calculator, okay? If you wanted to, you could rewrite this as any other base. All right. So why don't you just give me an integer right now, greater than 0. Anybody? Bobby? 7? Sure. Yeah, we can write 7. All right. So that would be log base 7 of 17 over log base 7 of 4. All right. All of those are equal. You can pick any number. Okay. It wasn't dependent on what Bobby said there. All right, so great, Paul, you're a dinosaur. We can put this in our calculator. Why would we need to know all of this? Well, we're going to go through some examples here of why you would need to know that. All right, look at this one here. Algebraically show that f of x equals log base 4 of x is the same as g of x equal to 1/2 log base 2 of x. Well, how could we do that? There's more ways than one to do that, but I'm going to start with f of x here, okay? So good practice showing equivalency throughout a problem is what we're going to do here. So let's say f of x is equal to log base 4 of x. Well, we just talked about a second ago that we can change the base. We can change the base to anything we want. But if I'm trying to show that something of base 4 is the same as something of base 2, then it would make sense to try to convert this into base 2. So based on that last formula, try to think in your head right now, what would we rewrite this as with base 2? Well, that would be log base 2, argument on top, old base goes as the new argument right there. Great. Awesome, Paul. Why does that help? Well, because you're starting to get these math sense with these logarithms, hopefully, that you know what that is. Remember, how many times do we multiply 2 by itself to get 4? Well, it's 2 times 2. So if this was written off to the side as just like, hey, log base 2 of 4 equals something, what would that something be? It would be 2 squared to give me 4. So this whole denominator is literally just the number 2. Oh, there's a 1 out front here, right? So this is equivalent to 1/2 times log base 2 of x. Hey, that's the same as. Do one where we're solving now, and clearly you can see, oh, I've been solving. All right, cool. These don't have the same base. So remember, those logarithmic properties only work when you have the same base, right? You can't just put things together. So what we're going to do here is we're going to be like, all right, let's see, 1/9. Base 3. I kind of want to turn 1/9 into base 3 because I like base 3 better. Who wouldn't rather work with a base 3 than a base 1/9? So I'm going to use the change of base formula. So I'm going to say, all right, log base 3, right, of what? Of x, all over, excuse me, log base 3 of 1/9 plus log base 3 of x equals -2. Okay, great. But what is that? Well, if this isn't too straightforward to you, I personally can look at this and see that that is -2, right? Because 3 to the -2nd power would be 1/3 squared, which is 9. Again, no shame in going off to the side of your paper and being like, all right, Powell says like, hey, it's got to be equal to something. So that would be 3 to the y power equals 1/9. Well, what would we have in here? Well, we'd have to kind of solve. We'd have to solve for this. That's 1/3 squared. 3 to the y power would be 3 to the -2nd power. And then you realize what that was. So this is -2. So however long it takes you, hopefully you'll get better at doing that fast. But this is just the number -2. Plus log base 3 of x equals -2. There are different ways to solve this from here for sure. But as you can see, we have everything with log base 3 on the left side. So me personally, I just like to do this. I like to multiply by -2. Okay, cancels here, distributes through to that one. So we're going to have log base 3 of x minus 2 log base 3 of x equals, multiply that side by -2. We're going to get a +4. And then carrying on, literally they are the same basis, right? So it's like 1 log base 3 of x minus 2 log base 3 of x's. So that would be -1. Log base 3 of x's equals 4. Divide everything by 1. You're getting log base 3 of x equals -4. And then, how do we get x by itself? Oh, we can convert to exponential form because I know that 3 to the -4th power equals x. And 3 to the -4th power is the same as 1/3 to the 4th power, which would be 1/3 times 3 times 3 times 3, which is 81. So I can get my answer right there for this problem. Okay, we do need to be careful. Remember, these right here are arguments. They are not allowed to be negative numbers. I don't have negative numbers here, so I'm good, but always look out for that. Okay, so let's change of base. Hopefully it helps, and good luck. Every problem's a little bit different with these.